science. In the last lecture we have discussed regarding to finite state machines. Then we have seen how the data which is provided as input will be processed by a machine, and it will generate output, as well as it will generate a new state, or it will remain on a same state. We already discussed regarding to that DFA, and we have already discussed regarding to non-deterministic finite automata. In this lecture we'll study how to design a DFA for a different inputs as well as whatever the expected output. So today we'll see a first problem, that is design a DFA to check a given decimal number is divisible by a 3-digit 3. So as we know, a basic decimal numbers are the numbers which are nothing but 0 to 9. So for designing a DFA we require an input set, so that is indicated by summation. So we'll take inputs, that is nothing but 0, 1, 2, 3, 4, 5, 6, 7 and 8 and 9. So this is nothing but the input which is provided for a DFA. Then we require a set of states. So set of states will take 3 states. One state is for remainder 0, one state for remainder 1, and another state is for remainder 2. Then we require initial state. We'll take an initial state, that is nothing but a Q0. Then we require a final state, and Q0 indicates it is having a remainder 0, means a totally divisible by a decimal 3. So the final state will be also Q0. Now we'll design a DFA for that particular problem. So we'll draw a state transition table. A state transition table will be having inputs, it will be having outputs, will be having a remainder 0 set, that is 0, 3, 9 and 6. These will be having remainder 0. Then remainder 1, 1, 4, 7 and 1, 4, 7. Then next we require a remainder 2. So we'll be having 2, then 8 and 5. So these will be having a remainder 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So all the basic decimal numbers are covered up in a input set. Okay, now we are having a states. First state is nothing but a Q0, another state is nothing but a Q1, another state is nothing but a Q2. Okay, so this indicates remainder 0, this for remainder 1 and this for remainder 2. Okay, so Q0 with 0. Okay, now I'll attach this 0 to this 0. 0 means it will generate a decimal number 0. So 0 divided by 3 is giving you 0. So it is totally divisible. So for remainder 0 we have a state, that is nothing but a Q0. Then Q0 with 1, it generates a decimal 1. So 1 divided by 3, it is generating a result remainder 1. Then next 0 and 2, so it is having a remainder 2, so we'll generate a state Q2. Then 1 0, it is giving me a 10, or 1 3, it is giving me a 13. Divided by 3, it is generating a remainder 1. So we have a state for remainder 1, that is nothing but a Q1. Then 1 1, we have a state for remainder 2, that is nothing but a Q2. Then 1 2, 12. 12 divided by 3, it is giving a remainder 0. So we have a state 0, Q0. Then Q2 with 0 or 3 or 9 or 6, 2 0, it is giving me a 20. So I'll be having a 20 divided by 3, remainder 2. So I'm having a state for remainder 2, that is nothing but Q2. Then for this K2 1, I'm having a 21. 21 divided by 3, it is giving a remainder 0. Then this 2 2, I'm having a 22. 22 divided by 3, it is giving me a remainder 1. So this is generating me some states. Okay, so this is a state transition table. Now I have to write all the equations, that is called as a transition equations. So transition equation will be written as like del with state, all the states with input, whatever the input we have seen, 9 and 6. So this particular q0 with this input, it is generating a q0, which we have already seen here in a table. Okay, q0 with this particular inputs generating these states. So similarly, I have to write for each and every input which is provided to q0, each and every input which is provided to q1, each and every input provided to q2. Okay, so this is giving me an output that is nothing but a q1. Similarly, for q0 with input 2, 5, 8. Okay, so it is generating me a q2. Similarly, I have to write a transition equations for q1, similarly for a q2. So this is all regarding to a transition equations, this is all regarding to a transition table. So now I have to draw a state transition graph. So for drawing a state transition graph, I require a state. So I know the states present for this particular DFA are nothing but a q0. So I'll write it q0. I'll draw it along with the circle. I'll show a start state along with the symbol, that is a starting pointer. Then I have a q1 state and I have a q2 state. And my final state is also q0, so I'll double circle it. Okay, every final state will be shown along with the double circle. Then now q0 with input 0, 3, 9, 6 is going to q0 itself. So I'll show that input on this particular arrow, and arrow goes to the same state. The next q0 with input 1, 4, 7 is going to q1, so I'm showing like this. The next q0 with input 2, 8, 5 or 2, 5, 8, it is going to a q2. Then q1 with input 0, 3, 6, 9 is going to state q1. The next q1 with input 147 is going to q2. 147. Okay, then q1 with input 285 is going to q0. 258. Okay, now over regarding to a q1 and q0, now we have to provide an input to q2. So q2 with input 0, 3, 6, 9 is going to that same state, means itself. Then this q2 with input 147 is going to q0, and q2 with input 285 258 is going to q1. Okay, so this is a total state transition graph for this particular problem, which is nothing but design a DFA to check a given basic decimal number is divisible by 3. Okay, so this is a first problem which we have seen on a DFA. Okay, so in the next lecture we'll see a second problem, that is nothing but design a DFA to accept even number or input basic decimal numbers.